Super excited to share with you all this presentation about securing data at scale, focusing on our implementation of Snowflake's native dynamic data masking and how we did it with dbt. So to introduce myself, my name is Ashley Van Name, and I'm the manager of data engineering at JetBlue. I'd also like to introduce members of my team that contributed heavily to this project. So Ben Singleton, the director of data science and analytics, and also Sergey Romanenko. He's a data engineer who I work very closely with, and he built most of the processes that you will see in this presentation today. So I'd also like to preface this talk with saying that my objective here is to give you a tactical overview of the process we built. And I'm also writing up a discourse article that will be going over most of what I discuss in this presentation. So don't worry about remembering all of the little tiny details. It will be available for you on discourse. So I'll jump right into it. I wanted to spend a few minutes talking about, why airlines should care about securing their data in their data warehouse, and more broadly, why you should care about doing it in your data warehouse, no matter what industry you work in. Specifically for us, you can think about our process by just thinking about what happens when you book a flight. Maybe you go to jetblue.com, you pick out an awesome flight to the Bahamas, you enter your information, you hit submit, and boom, like the next day you're in paradise, right? So when you book your flight, most of that information is that you enter in your online forms is sent to us in a series of data files. Those files are then secured and loaded into Azure Blob Storage, and then we load that data into Snowflake, where we transform it using dbt. Of course, every pathway along this route is secured. So think about what those forms look like when you are trying to sign up for a flight and buy a ticket, right? What kinds of pieces of information do you actually enter there? You're entering your first name, your last name, your birth date, your emergency contact name and phone number. Your IP address is getting captured somewhere, and all of that information is getting sent over to the airline that you're doing business with. And it's our duty as an airline to not only keep you safe in your travels, but also ensure that all of your data is kept safe and secure in our data warehouse and anywhere else that we store it within our company. So some airlines have gotten into financial trouble for not properly handling personal data properly. They've been hit with major fines for GDPR violations. And quite honestly, this is never something that we want to deal with, but especially in this challenging time for our industry, we do not have any money to spend on any sorts of fines due to us not properly handling customer data. And so for that reason, when we started off on this huge journey to move our on-premise data warehouse into the cloud and into Snowflake using dbt, we needed a way to make sure that we kept passenger and crew member data secure while we also enabled analysts to access the data they need to do their jobs, right? There are some groups at JetBlue that do need access to to certain pieces of sensitive information, and that's just part of their job description. And so we needed a way to build this out in Snowflake and make sure that only the groups that have access or that need access to the data are the ones that actually get access to it. So our first attempt at doing this was setting up what we called private schemas inside of our data warehouse. We got this idea from a discourse article, and at the time that we decided to go this route, we thought it was the best decision. So essentially, what we would do is we would create a copy of any data model that contains sensitive information, and we would materialize the model in two separate schemas. So one schema would be suffixed with underscore private, and in that schema, the model would show all sensitive data fully exposed. So for example, on the bottom right-hand corner of the screen here, there's a table called analytics booking underscore private dot passengers, right? And in that table, we expose the first and last name of the passenger in this case. Then we would also create a second schema called bookings, which doesn't have that underscore private suffix on the end of it. And the passengers table in that schema would show a hashed value for the first and last name. So no sensitive data was exposed in that version of the model. So then when a small number of analysts, actually needs access to the sensitive data, we would specifically grant them access to the bookings private schema in this example. And this really just meant that when they wanted to or needed to access that data, they would have to change their query and repoint it to use the model or the table built out in this new schema, bookings private. So There's also another side to this method, right? When you build out a private schema, you also need to think about, okay, well, how do you actually build out the non-private version or the public schema? And how do you hash those values to make sure that no one is able to decode them? And so this pretty much was straight out of the discourse article. What we did was we built a table in our raw database that only account admins had access to. And that table contained a random string of letters and numbers, which we would then select from and join to our sensitive data fields in any model. And so when we combined that secret salt with the column value and applied an MD5 hash on top of it, we would get this series of letters and numbers in our data table that really couldn't be decoded by anyone if they didn't have the access to that secret salt value. So overall, this approach worked, right? It helped us to secure our data in Snowflake based on role-based access control, and also enabled us to share more data with analysts, given that we were able to hash out sensitive fields in the data tables that did contain sensitive data. But it did have some drawbacks. So as I previously pointed out, it forced analysts to repoint their queries to new schemas, which was they just sort of saw as an annoying thing to do. And it also, on the engineering side, increased our code base a lot. We had to keep essentially duplicates of each model that contained sensitive information. And overall, that increased our total repo size by about 35%. Whenever you add additional models into your repo, it's also going to increase your compilation times, which we didn't really like either. So overall, while it did the job, it just wasn't really the best thing for us. And so we started to think, well, what if we had one version of the table that everyone could work with, right? Let's think about getting rid of having two schemas and two separate versions of each model when we want to expose or hide sensitive data. At the time we were thinking about that, we saw that Snowflake introduced their dynamic data masking feature, which is really, really great. It's available for all enterprise customers now, and it's in preview for all accounts. I'm not going to spend too much time talking about the specifics here because it's all available in Snowflake's awesome documentation. But what you need to know is that dynamic data masking is a column level security feature that uses masking policies to selectively mask plain text data in a table at query time based on the user's role. So this leads me into our second attempt. We decided we wanted to get rid of private schemas, move towards this new way of masking data using this new feature from Snowflake. Dynamic data masking allowed us to define these masking policies, which would then expose sensitive data only to the users, which we specifically said should have access to it. Otherwise, they wouldn't see any of that data. So if you look on the right side of the screen, from what we did was we essentially now have one table, analytics, bookings, passengers, and depending on the role that you use to query the table, you'll see one of two things. If you have access to sensitive data, you'll see the table on the bottom with first and last name exposed. But if you don't, you'll see the table on the top, which has asterisks for first and last names. So this was great because analysts didn't need to repoint their queries. If they needed to look at sensitive information, they could still continue to use the same table as long as they had access on the masking policy. And we also were able to slim down our DBT project by a lot. We were able to remove a lot of the models that were duplicated, so it caused our compilation times to decrease, which we really liked. So for those of you who aren't familiar with what this looks like in code, I put this up here just for illustrative purposes, but essentially a masking policy is a schema level object. It works just like sort of like a table or a view. It's an element that you create in your schema, and you can apply a masking policy to any column in any table or view in that schema where the masking policy exists. So it works like a case one statement. You essentially say case when your role is in this long list of roles, whether you're an analyst or some other role, then you can see the actual value in that data column. Otherwise, if you're not using a role in that list, then you'll get a string back in this case of what is that, maybe 6 or 10 asterisks in the data table itself. And so you won't actually see any of the sensitive data in a column that has this masking policy applied if you don't have the analyst role in this case. So, we decided on this method, and then we said, Well, we really need a way to implement it easily in our DBT models in order for us to really scale this up and implement it and roll it out across all of our data models that existed in our project. So we created a macro to do this. The macro is super simple and easy to use. We run it in a post hook. I put a little screenshot on the right side here just to show you really how simple it is. It's called apply data masking, and it takes an input list of columns that you would like to mask in your model. So here in this example, this is the config block to a model that it has passenger first name, last name, and emergency contact information. And we decided, that data is definitely sensitive. We definitely want to control it more than non-sensitive information. So we want to apply some sort of masking policy on top of it. Before you start copying code in the next section of this presentation, again, just want to reiterate all this will be available on Discourse. I really wanted to, put this section of the presentation in to walk you through how our code works. Whenever I attend conferences, I really like to see how people actually implement features rather than just describe them. So I hope this section is useful. Essentially, the first way we kind of get the ball rolling on this is that we create a DBT model that calls this apply data masking macro in the post hook. After we do that, the macro handles everything from there. So the first step that the macro does is it sets the context of the model that is being built, and specifically the model that is calling the post hook. So it will capture things like the type of materialization that the model is. So is it a table? Is it a view? It will capture the database name, the schema name, and any alias you may have applied in the config block of the model. So these parameters help us to define and apply the masking policies at later steps. Once we get the context for the model and we know where it's being created, then the macro will create two masking policies in the schema if they don't already exist. One that masks strings and the other that masks dates. So by default, the transformer role should have access on the masking policy and should be the only role that should be able to see sensitive data until you specifically grant it to other roles. Everyone else will see masked data values by default. So how does this actually look? Here, the little code snippet just says, create your masking policy if it doesn't exist in the schema where your model is being materialized. And this is an example of how we created that text or string masking policy. We call it masking policy text. And then it looks very similar to that example that I showed previously, where it's just a case when statement. It looks at the current role of the person who's executing the query. And if it's not the transformer, then sorry, you're only going to see asterisks in the results. You're not actually going to see the value of that sensitive data field. Once the masking policies are created, we then run an alter table or alter view command on the model that we're building. And what we alter about it is that we actually apply these masking policies. So we modify the column for each column in that list that we send to the macro at the start, and then we set the masking policy equal to masking policy text for any text fields, and we set it equal to masking policy date for any date fields. So if that was a lot of code a little bit too quickly, the big takeaway here is, what does the apply data masking macro actually do? At the top of the screen, you'll see, imagine this is your original model with no data masking applied, all the sensitive data exposed. After you run the post hook and you call the apply data masking macro for the name field, the date of birth field, and the address field, if you go and then query the table in Snowflake, you'll see that if you are using any role other than transformer, you'll see a bunch of asterisks for name and address. And for date of birth, you'll see this fake date some point way in the future that doesn't really have any association with the actual value of the record. Whereas if you query the same exact table using the transformer role, you'll see all of the data as you would expect based on the original model. So now the last piece of this puzzle is that we needed a way to actually grant user groups access to this masking policy. There are some roles within our company that really do require being able to see, for example, a customer name on a booking. And so the setup that we previously just discussed kind of looks like this, where Transformer has access to everything, but customer support can't see any customer names in our data warehouse, and maybe finance can't see any sensitive data that is stored in our voucher schema. Execs can't see anything, so we needed a way to give them access, and this is how we did it. We created another macro called create sensitive role with masking policy. I'm not going to show any code for this one. I'll post it online, but the concept here is for each schema, we created a sensitive role. So for the booking schema, we created a sensitive bookings role. And for the voucher schema, we created sensitive vouchers. And then we actually grant those roles to individual user groups if they require access to that information in order to do their job. So what did dynamic data masking actually help us to accomplish, and how did DBT help us in it? Well, it helped us to achieve data security and control within Snowflake. So by implementing dynamic data masking with dbt, we were able to grant analysts access to versions of data sets that don't expose any sensitive information, which means that we're actually able to provide a lot more data to a lot more people, knowing that it's secure and that only those who really require access to sensitive information are granted access to it. The macro implementation really helped us to work towards more simpler, drier code. We love that we were, not only able to slim down our dbt project by removing the strategy of private schemas, but we were also able to implement this macro that, kind of just is, you think about it once, you make sure the logic all works, and then you can apply the same method of data masking to all future macros, and it's really easy to do. Furthermore, we are really confident now in our ability to report to audit and compliance when they want to come to us and say, hey, who has access to what data source in your data warehouse? Now we have these sensitive roles where we can easily pinpoint which groups have access to which pieces of sensitive data, and it makes that type of reporting really easy. And above all else, we really have peace of mind now. We know that only a limited group of analysts has access to our sensitive data in our warehouse, and it helps us sleep easier at night. I mean, no one wants to be a member of the data engineering team at a company that has a big data leak because improper security was not in place in the data warehouse. So this feature and our implementation of it using dbt, makes us all feel a lot better about what we built. So I'd like to take a few moments just to highlight what we're thinking of next. You may have noticed as I was going through this in our original implementation of private schemas versus non-private schemas, we had this long hashed value, which really can actually operate as, you can use it to join tables together or aggregate on values, whereas in our current implementation, by using asterisks to hash out all sensitive values, you kind of lose that. And so, we realized this a little bit late in our implementation of this dynamic data masking method. And so this is something that we want to go back and do to enable the hashing to still sort of give a little bit of value to the end user, but also still not expose any of our sensitive data to anyone that shouldn't have access to it. We're also thinking of trying to make this a little bit more modular. So right now, we have one single masking policy for each schema. So when an analyst is granted a access on that masking policy, they're able to see sensitive data for all the tables in that given schema, which is usually associated with a single data set. And generally that's the permission that we would grant anyway, but we see additional value in further segmenting this to include things like groupings for different types of sensitive information within that schema. So really we should probably have a masking policy just for names, another masking policy just for dates of birth within the same schema, so that we can pick and choose which types of elements people have access to based on what they actually need, rather than grant them access to all the sensitive data in one single schema. And with that, just some closing notes. If you are thinking of implementing something similar at your company, just some pieces of advice and things that we sort of learned the hard way. The first one is I definitely don't advocate for private schemas. It will just add additional overhead into your project and upset your end users, and also increase your compilation times, which is just going to cost you money. So definitely, if you're using Snowflake and you have access to the dynamic data masking feature, definitely go that route. Don't make the same mistake that we did. Don't mask your strings with asterisks. I would say figure out how to get the assault with an MD5 hash working properly. That will give you a little bit more value for your end user. They'll still be able to do joins and aggregates across tables. And also, definitely don't implement this without using the applied data dynamic or applied data masking macro. It will save you a ton of time and it will make sure that all of your data masking policies are consistent throughout your project. And again, make sure to be on the lookout for our discourse article that will be coming out soon, which will walk you through this process again and give you a little bit more insight into the code that we use to implement it. So with that, I'd like to thank you very much for listening, and I look forward to chatting with you all in the DBT Slack channel.